the first of those big rules is probably the most important, because this golden rule here, that's what keeps the equations. That's what keeps it equal on both sides. If you do something on one side and you don't do it to the other, then they're not equal anymore. All right, so to make sure that they stay equal, we have to do the same thing to both sides. And remember, we draw that line of equality to remind ourselves of that. Another one of the big rules, and this is really just our goal. So when solving an equation, the goal is to what? When we're solving an equation, the goal is to get the variable by itself. All right, so whatever the variable is, we identify the variable by doing what? We identify the variable by doing what? Circling it. So whatever that variable is that we circle, we want to get that by itself. So if it's on the left side of the line of equality, then there shouldn't be anything else on the left side. Or if it's on the right side, then there shouldn't be anything else on the right side. So we want to get that variable by itself. Now, to get the variable by itself, we have to get rid of some numbers most of the time. If we didn't have to get rid of anything, then it would be solved for us already. So to get rid of a number in an equation, what are we going to use? Inverse operations, exactly. So to get rid of a plus 7, we do the opposite of plus 7, which is minus 7. So the opposite of adding is subtracting. So when we say inverse, we mean opposite operations. Okay? So we're always going to do the opposite. To get rid of addition, we subtract. To get rid of subtraction, we add. To get rid of multiplication, we divide. And to get rid of division, we multiply. All right, so the only new thing we're going to do today, which isn't really new, is we're going to do this with multiplication and division problems rather than adding and subtracting. So the first example, you need to write the equation down. It says a divided by 5 equals 3. So write that equation down. And we'll go ahead and solve these together, at least to start with. So the first thing I'm going to do is what? Circle the variable. So I want to remind myself that variable needs to get by itself. And draw the line of equality. Draw it nice and long so our equal signs all end up on that line. And then I need to get rid of something to get the a by itself. What do I need to get rid of? 5. How am I going to get rid of this divided by 5? Multiply by 5. All right, so we can show this in a few different ways. You can just write times 5 down here. You could, if you wanted to, put the times 5 out front, except I don't have any space there to do that. But you could put the times 5 out front like that. I don't really like this because it's not easy to show that they're going to cancel out. So I would probably just write it underneath. So times 5 there. And I'm going to use the dot because we like to use the dot. So we're multiplying by 5 here. That gets rid of the 5. But if we do that, what do we have to do? Do it to the other side. Golden rule says if we do it on one side of the line, we have to do it on the other. So we're going to multiply by 5 here. All right, now we simplify. Just like any other equation, once we do that, we have to simplify it. What's going to happen here? Yeah, the divided by 5 and the times 5, those cancel each other out. So what's left on the left side? The A. And on the right side? 15. Okay, do we have the variable by itself? Yep. Done. Example 2. So this time we have b times 4 equals 36. So what's the variable here? B. So we'll circle that. Draw our line through the equal sign. And we want to get that b by itself. To get the b by itself, we have to get rid of the 4. And what's the opposite of multiplying by 4? Divide by 4. The easiest way to show division is using a fraction bar. So we're going to use a fraction bar and put the 4 underneath it. This just means divided by 4. It would not be wrong. It doesn't look as clean, and it might cause some confusion with some things that we're going to do later on. But it wouldn't be wrong if you did this. I would prefer to see the fraction bar though. Okay, so we divide by 4 on the left side to get rid of that 4. But if we divide by 4 on the left, we have to divide by 4 on the right. Okay, so now we simplify. On the left side, what's going to happen with these 4's? They cancel. Okay, so just like when we add and subtract, they cancel each other out. When we multiply and divide, they cancel. 4's cancel. B is left by itself. 36 divided by 4 on the right side is 9. Example 3. We have 8c equals 32. Now, I think you know this, but let's just remind ourselves. If we have something like this, where there's no operation in between, it's just a number next to a letter, what does that mean? It means multiplication. So this means the same thing as 8 times c. So keep that in mind when we're solving for c here. We do want to get the c by itself, so I'm going to circle that. And still have to use the golden rule, so draw my line of equality. And so we have 8 times c. How do I get rid of that 8? Divide by 8. How do we show division?
With a fraction bar.
With a fraction bar. So we put that fraction bar and put the 8 underneath. Alright, that means divided by 8. So if we divide by 8 on the left, we have to divide by 8 on the right. And now we simplify. On the left side, what are the 8's going to do? They cancel out. What's left? C. On the right side, 32 divided by 8 is 4. So we get C equals 4. Now, this is an example where it looks like we have a fraction, and we really do have a fraction, but we're not going to treat it like a fraction. It means divide, exactly. So when we do problems like this, we're going to treat this as a division problem. Okay, this d over 3 really means d divided by 3. So we're going to treat this as a division symbol and do the problem accordingly. So first thing I need to do, as always, circle the variable and draw the line. And so to get the d by itself, what do I have to get rid of? I have to get rid of the 3. So this is a divided by 3. What's the opposite of divided by 3? Times 3, or multiply by 3. So we're just going to put that out front. So I'm going to put 3 times out front, so it's 3 times that fraction. And on the right side, what do I need to do? Same thing. Whatever I did on the left, I have to do on the right. So I multiply by 3 over there. All right, now, I put the times 3 out in front of this fraction, to the left of the fraction, just because that's where I had space. It doesn't matter if it's in front or behind like I have it on the right side. It means the same thing. As long as we're multiplying the whole thing by 3, it doesn't matter if it's in front or behind. Now when we simplify, what's going to happen with these 3's here? They cancel out. Alright, so we're going to have the 3's cancel, and what's left on the left side? On the left side is D. The left side. Then on the right side, we have 7 times 3, which is...
Hey guys, there's a lot of extra talking that should not be going on.
Example 5. Now we've got some negatives in here. We have to be really careful we keep track of our positives and negatives correctly when we're doing these. Alright, so this is negative 7e equals 28. Since there's no operation here, that means we're doing what? It's multiplication, right? So this is negative 7 times e. So we're going to circle our e, draw our line, and to get rid of that negative 7 then, we divide. This is probably the most missed type of problem that we see with solving equations. Because what most people want to do, you want to guess? To get rid of a negative 7, what did we used to do? Add 7. But we don't add here because this is a multiplication problem. And addition is not the opposite of multiplication. So be very careful here. Okay? To get rid of this negative 7 here, we have to divide. Now, what are we going to divide by? Positive 7 or negative 7? We have to divide by negative 7. the opposite of multiplying by negative 7 is dividing by negative 7. If we divide by negative 7 on the left, then we have to divide by negative 7 on the right. We need to simplify now. What's going to happen with the negative 7s over here? They cancel out. Now, I want you to notice that really we could think about it as the 7s canceling each other out and the negatives canceling each other out. Okay? It's important that we divide by the negative here, because if we don't, then this negative is going to stay here. If we just divide by 7, it'll cancel the 7 out, but not the negative. And so we would end up with negative e here. And that's not what we want. We want e by itself. All right? On the right side, we have a positive number divided by a negative number. So we'll deal with that later. But what is 28 divided by 7? That is 4. All right, so I've got e by itself on the left side, equal sign on the line, and I've got a 4 over here. Now, is that going to be a positive 4 or a negative 4? Why is it negative? Okay, if you remember our rules for division, if you have a positive and a negative, the answer is always going to be negative. It's the same thing as multiplication, exactly. All right, so we get e equals negative 4, and that is our final answer. Example number 6. We have f over negative 3 equals negative 2. Or instead of saying f over negative 3, we could say what? F divided by negative 3. Exactly. So we'll start by circling the variable, drawing a line. And we want to get the f by itself, so we have to get rid of the negative 3. All right, so this is f divided by negative 3. What's the opposite of dividing by negative 3? Multiply by negative 3. All right, so we're going to multiply out front here and put our negative 3 there. So we're multiplying by negative 3 out front. And if we multiply the left side by negative 3, we have to do the same thing on the right. Exactly. So we're going to multiply by negative 3 out here. Now, personally, I don't want to get confused and think that this is negative 2 minus 3 instead of negative 2 times negative 3. So what I would probably do is put parentheses here. You don't have to do that, but make sure that you know what you write down. Make sure you know what it means, whatever it is that you write down. So if you write something down and then you go back and you interpret it differently, can't blame us for that. So make sure that you write down something that's not going to be confusing to you. Okay, so over here, what's going to happen to the negative 3 and the negative 3? They cancel out. Again, you can think about it as the 3's canceling out and the negatives canceling out. Okay, if we didn't have that negative on the 3 here, then we would still have a negative down here, and we don't want that. We want to get rid of it. All right, so those cancel out, and what's left on the left side? F. And on the right side, we have negative 2 times negative 3. What's 2 times 3? 6. Okay, what's a negative times a negative? Positive. Negative times a negative is positive, so that's going to be a positive 6. Example 7. So this example, we have a little bit of a different notation here. We have a g and then a parentheses with a negative 2 in it. Does this mean g minus 2? What does it mean? Times. So again, we have the g next to something without an operation in between it. That means that it's multiplication. So this is the same thing as g times negative 2. So you can pretend like there's a little multiplication dot in there if you want. You don't have to, but it might help. All right, so we still want to get the variable by itself, which means we're going to circle it. We want to draw our line through the equal sign. Remind ourselves that whatever we do on one side, we have to do on the other. And now what do I have to get rid of here?
12.
So we need to get rid of that negative 2. Do we do that by adding 2?
No.
Why not?
I mean, no, because it's dealing with the multiplication.
Okay, good. So this is multiplication. The opposite of multiplication is not addition. So this is really similar to the one I said that a lot of people miss. It needs to be division, right? So we're going to divide here. Now, what do we divide by to get rid of that negative 2?
12. We divide
The 12 doesn't have anything to do with it. What do I divide by to get rid of the negative 2?
Negative 2.
Negative 2, exactly. Again, that negative there is important because without it, we're not going to get rid of the negative up here. All right, so we divide by negative 2 on the right, which means we have to divide by negative 2 on the left. And what is negative 12 divided by negative 2? Well, let's
6.
Let's think about this. What's 12 divided by 2?
6.
6. And a negative divided by a negative
It's a positive.
is a positive. Remember on the last couple examples I said we can pretend like the negatives cancel each other out?
Yep.
That's exactly what's happening here. These negatives are really canceling each other out, and so it's just 12 divided by 2, which is 6. On the right side, the 2's are going to cancel each other out, and the negatives cancel each other out. So the negative 2's as a whole cancel each other out, and the G drops down. So we get 6 equals G. Example 8. So we have negative 7 equals H over 3. I think this one's going to be pretty easy, I hope. So I want to get the H by itself, so I'll circle it, draw the line through the equal sign. And so to get the H by itself, I need to get rid of what? To get the H by itself, I need to get rid of what? The 3. All right, so what's the opposite of dividing by 3? Multiply by 3. So I'm going to multiply by 3 there. Now that's going to get rid of this 3, but if I multiply the right side by 3, I have to multiply the left side by 3. Okay, now could I just do this?
No.
Why not?
You could put it in parentheses.
Okay, I could put it in parentheses, or I can't put the times in front, right? I need to put it between. So if I'm going to use that dot, I can put it like this. Now that looks like it could mean 3 minus 7 if you miss the dot here. So what I would do is not put the 3 in parentheses, but put this negative 7 in parentheses. Okay, if you want to make sure it's clear. Or you could even put both of them in parentheses. Then it's really clear. Then you know for sure it's multiplication. So what is 3 times negative 7? Okay, good. So 3 times 7 is 21. This is going to be a negative 21 because...
Because
Not because the 7's bigger.
Because a positive times a negative is a negative.
Yeah, always. A positive times a negative is a negative. Doesn't matter which one's bigger, it's always going to be negative. All right, so we get negative 21 on the left. On the right, what's going to cancel? The 3's. And so what's left? The H. So we get negative 21 equals H. Example 9. 13 equals negative I. Now, well, let's start this like we would any other one. We circle the variable, draw the line. So the question is, my question is, what do we need to get rid of?
No, the negative.
The negative, right? We want to keep the I here, but we want this to be by itself. So I have to get rid of this negative here.
Make the negative one.
Exactly. So if there's no number in front, what is the coefficient? The coefficient's the number in front of the variable. So if there's no number there, we can just pretend like it's a 1. So what we'll do is we'll pretend like this is negative 1i. If we think of this as a negative 1i, that's really the same thing as negative 1 times I, right? So how do I get rid of that negative 1? Don't add 1. This is negative 1 times I. What's the opposite of multiplication? Division. So we're going to divide by... No.
13.
So to get rid of that negative 1, I divide by negative 1. If we just divide by 1, we're not doing anything. We're not getting rid of that negative. All right, so I have to divide by negative 1. If I divide by negative 1 on the right, I have to divide by negative 1 on the left. All right, so on the left side, 13 divided by 1 is what? Answer the question. 13 divided by 1 is what? 13. All right, now if we think about the positives and negatives, a positive divided by a negative is a negative. Okay. On the right side, what's going to cancel? The negative ones, right? So the negatives cancel, and really that's the important thing, because the ones don't do anything. What's 1 times I? It's just I, right? And what's I divided by 1? I. So the ones don't really need to cancel, but they're gone also. But what's important is that the negatives cancel. So all that's left is I. So we get negative 13 equals I. I want you to notice for this problem, we started with 13 equals negative I, and we ended up with negative 13 equals I. So if you have an equation like that, basically what's going to happen is the negative's just going to move over. Now, we can't really just move the negative sign. We have to show how we got the negative sign over there. But that's basically how it's going to end up. All right, last one. 1 equals j divided by negative 1. Again, just like always, we're going to circle a variable. Draw our line through the equal sign. And this time, what do I want to get rid of? I do not want to get rid of the 1.
Negative 1.
I want to get rid of the negative 1. Remember, I want to get the j by itself, which means I have to get rid of anything that's on the same side as the j. So I'm going to get rid of this negative 1. What's the opposite of dividing by negative 1?
Timing.
Multiply by negative 1. So I'm going to multiply by negative 1. Again, I'm going to use parentheses to make sure that it doesn't look like a subtraction problem. And if I multiply by negative 1 on the left, what do I need to do? Same thing, or I'm sorry, I did it on the right, so I need to do it again on the left. So I'm going to multiply by negative 1 here. What's 1 times 1? 1. And a negative times a positive? Negative. So we get negative 1 on the left. And on the right side, what's going to happen with the negative 1s? They cancel. And the important part there is the negatives cancel, right? If we didn't have the negative here, then the negatives wouldn't cancel. All right, so what's left here? The j. So negative 1 equals j. This is actually the same thing as the last one. All that really happened here was the one on this side changed signs. So it became, instead of being a positive, it became a negative.